tutorial 3 for chapter 3. Please watch this video till the end for tutorial chapter 3, logic gates. So let's share the PowerPoint. Present now. Window. Okay. This is the tutorial 3. Digital logic design. Let's have the slide view. Sorry, slide view. Okay. Example 1, develop the truth table for 3 input AND gate. Truth table, 3 input AND gate. If you refer to the notes, what is the symbol for AND gate? How to draw the 3 input of AND gate? And the truth table is to describe the AND gate. Okay. Describe and okay. So that's the function of truth table. Okay, so 3 input, you can just give any variable to the input A, B, C. It gives any output X, something like that. So please remember this combination of truth table, the input, the binary input, repeat 0, 1, 0, 0, 1, 1, 3 bit. 3 inputs, so 3 bit. So what is X? Truth table, so you just fill it in this X. Refer to the slide, the function of AND gate is like multiply. Okay. Multiplication, so 1, 1, 1 is 1. Other, if you have only 1, 0, then okay. So the symbol, please draw it carefully. X, because X is the output, and 3 input A, B, C. So that is how to construct the truth table of for 3 inputs. Okay. So refer to the slides, go to the reference books, then hopefully you can understand. Please don't just rely to the slides. Help yourself to also find the other resources. Okay. Truth table for 4 input AND gates. Okay, this is the truth table for 4 input AND gate. 1, 2, 3, 4 output X. So you can see the for the AND gate. Go to the definition, look at the definition, then you can understand the behavior of the AND gate. Next is a waveform. All right, waveform. What is a waveform? waveform, determine the output waveform. This is the output, this is the input. In the example 1, the input is in 1 0 1 0 1 0 0 like this. Okay, but there is input in a form of waveform. Okay, waveform. Same thing actually, but the input is in waveform. Waveform means that wave lah. The input is continuously connected to the waveform, connected to the input continuously. So A, so this is A, 0, then 1, then 0, then 1 into input A, into input B, into input C. Then what is the output X? So X must be in a form of waveform as well. Okay, so how to draw? You have to bear in mind that any output, any input must be referred to truth table, because the truth table is describe the gate. So you can start anywhere. I mean, start at any point as long as you have the value of input change. For example, at this point, this is 0. Okay, 0 0. Why we take this at other point here? Because B has been changed to 1. So let's start with 0 0 0. So 0 0 0 refer to the truth table of gate of AND gate. So the output is 0. So you draw 0. You just draw 0. Right. Next, this one is 0. Now it's become 1. Now it's become, oh, sorry, no, wait, it's not 0. This one is not 0. This is 1. 1. So 0 1 1, still 0. Okay, the truth table or the function of gate and gate is like multiplication. If you have 1, if you have 0, automatically the output is 0. Then so on and so forth. So you just draw based on input of A, B, and C, either 0 or 1, refer to truth table, then draw the waveform. So the waveform, the output waveform is look like this. So this is the output of waveform. Very easy. So it's similar goes to the example 3, but this one is OR gate. You have to remember that how the function of OR gate or the truth table of OR gate, refer to the nodes, refer to the slides. From the truth table, then you can get the output if the input is 0 0 0 1 0 0, so on and so forth. Then you can draw the output. So the output is at any changes of the input. Now, see, this is a change from 0 to 1, then you draw, you get the output. If 1 or 0, just refer to the table for the gate, or then you get the output. So next, if you have this kind of circuit, logic circuit, this is logic circuit of what? No, right? No, of inverter. Okay, not of inverter. So this is the combination, all not. There is no other gates. So what are the output if A equals to 1? A equals to 1. What is the output? So go to the truth table of not. Then from the truth table, you can know the function of not. Not is inverter. Input 1, then output 0. Output B0 becomes input to the next gate not. Okay, then 0 here become 1. So this one go to here and also go to down here. One for this gate, one becomes 0. So one for this gate becomes 0. All right, because here is 1. Okay. Then for the E, this one 0. So E equals to 1, F equals to 0. So that is how you analyze the logic circuit of inverter. So there are 4 inverters connected like this. Then you can analyze when you have input A. So you can get what is the B, what's the C, D, E, and F. Very easy. Determine the output waveform. Okay, this is A, this is B, this is a NAND gate. So refer to the truth table of NAND gate. Then you can draw the output waveform of X. Very easy also. Okay, so this is another type of circuit. Determine the Boolean output expression. Okay, this is a different question. Boolean output expression is not the output of logic, but expression. What is expression? Expression is like A equals to something like that. X equals to A, blah, 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 plus what, blah, blah, blah. So that is the meaning of expression. Okay. So how to read this circuit? So we can do this connection here. This is the input lah. Then this node here is showing the connection. Means that this input is connected to A, because you can see the this draw. I mean the pin connection here. All right. So this B is goes to this one. This is how to read this. So you can see here is A bar, here is B, because this is the connection. Here is A bar, here is B bar. Okay. Okay, we hide this one. Here is A and this is B. So you get the expression x1 equals to what? This is AND gate. X1 equals to A bar dot B. This one equals to A bar B bar. Okay, this one equals to A. Still don't understand? Refer to the slide. Okay, how's the function of AND gate? Still don't understand? Refer to the note. Still don't understand? Go to the video. Watch the video. Go to the YouTube. Find the Logic Digital video. Okay, so ask your friends or ask me as well. All right. Okay, next is a more complicated one. This is more to the design. All right, design. Okay, for the quiz or test, normally test or final. So this kind of question normally a lot in a final exam or test. Don't expect the direct question. It's more to the design. So this is the design. The questions. Sensors are used to monitor the pressure and the temperature of a chemical solution stored in a vat. The circuitry for each sensor produce a high voltage when a specified maximum value is exceeded. An alarm requiring a low voltage input must be activated when either the pressure or the temperature is excessive. Design a circuit for this application. Sometimes when you read, you don't get the meaning of the term. That's one problem. Second, you don't understand what is the question all about. You don't understand what this question want. Okay, and if you don't understand that, then how you going to design? So read again and again until you understand. If you don't understand, try to get the key points. All right. Okay, so read again. Sensors are used. So we use sensor to monitor pressure. What to monitor? Pressure and temperature. To monitor pressure and temperature of a chemical solution stored in a stored in a tank lah. Okay. So we need a circuitry for each sensor. The circuitry for each sensor produce a high voltage, high. Okay. In the logic digital, if there are only two, high or low. High is 1, low is 0. So that sensor, it produce high voltage. Produce means that the output is high. When a specified maximum value is at C, bila some input value is at C. Bila value terlebih, sensor akan trigger high voltage. High voltage means that if in the logic design, 1, output 1. Bila dia maximum, output 1. An alarm requiring a low voltage input. An alarm requiring a low voltage input must be activated when either the pressure or the temperature is excessive. Design a circuit for this application. So what is the input? What is the output? That is very important in the design. What is the input? What is the output? The output is alarm. Okay, alarm. So in order to trigger the alarm, it is required low voltage. Logic 0 to activate the alarm. So what is the input? What is the input, or what is the measurement to trigger the alarm? So the measurement is temperature and pressure. So how to measure the temperature and pressure? Using sensor. That is the design. So the output is alarm. The input is pressure and temperature. Very simple. Okay. 0, 0, 0, 1, 1, 0, 1, 1. Very simple. Okay. So, okay, let's go back to the question. Exceed the circuitry for each sensor. So sensor for each sensor, which is sensor for pressure and sensor for temperature, produce a high voltage when a specified maximum value is at C. High voltage logic 1 lah. Bila dia punya value terlebih. Kan, sensor pressure terlebih, temperature terlebih, dia akan bagi logic 1, logic high voltage or logic 1. Okay. So alarm will be triggered when high voltage, when this value is exceed, when this value is exceed. So means that either one value is exceed, pressure or temperature exceed, alarm must be on. right? Alarm must be on. In order to on the alarm, it is required low voltage. Okay, let's go to the truth table. Sensor pressure 0, sensor temperature 0. Alarm or not alarm? Acid or not acid? Okay, acid pressure or not acid pressure? It's accident. Now acid, because acid bila 1, kalau 0 tak acid. Alarm bunyi tak? Tak bunyi. Tak bunyi, maksudnya kita kena bagi 1 ke 0? 1. Alah, 0. Sebab in order to trigger the alarm, it must be low voltage. So 1, tak ada alarm, alarm tak bunyi. 0, 1, bunyi tak? Alarm. Bunyi, because 1 ni means that exceed, temperature dah exceed. So alarm, please, alarm, on alarm. In order to on alarm, it requires low voltage. So 1 sini 0, 1, 1 boleh. So go to the truth table, find what is the gate of this truth table. So the gate is a no gate. Alarm. So this is how to design alarm circuit. Just use one no gate. Okay? It is enough to have the alarm for to detect the pressure and temperature, acid and pressure and acid temperature. Very simple. Okay, so that's end the tutorial 3. Okay, go and find a few other questions in slides, also in textbooks. Do a lot of exercise for your midterm test. Thank you very much. See you again. Bye bye.